In software development, managing data access and organizing code in a maintainable and scalable manner are crucial considerations. The repository pattern is a widely adopted architectural pattern that provides an elegant solution to these challenges. By encapsulating data access logic, it promotes separation of concerns and improves code maintainability. In this video, we will delve into the details of the repository pattern, explore its benefits, and discuss its implementation. What is the repository pattern? The repository pattern is a design pattern that provides an abstraction layer between the data persistence layer and the business logic layer of an application. It acts as a mediator, encapsulating the logic required to fetch, store, and manipulate data. The pattern promotes a clean separation of concerns by isolating data access operations from the rest of the application. Key benefits of the repository pattern. Separation of concerns. By isolating data access logic in a repository, the repository pattern separates data persistence concerns from the business logic, making the code base more maintainable and testable. Code reusability. With the repository interface and implementation, it becomes easier to reuse data access logic across different parts of an application or even different applications. Improved testability. The repository pattern facilitates unit testing by allowing the mocking or stubbing of repository interfaces, enabling isolated testing of business logic without touching the underlying data layer. Flexibility and scalability. The repository pattern abstracts the underlying data storage mechanisms, allowing developers to switch between different data sources, example databases, web services, or in-memory storage, without impacting the rest of the application. Repository pattern implementation. Repository interface. The first step in implementing the repository pattern is defining a repository interface that declares the operations to be performed on the data, example create, read, update, delete, commonly known as CRUD operations. Repository implementation. Concrete implementations of the repository interface provide the actual data access logic. They interact with the data source, example a database, and handle operations such as querying, inserting, updating, and deleting data. Business logic layer. The business logic layer of the application relies on the repository interface to interact with the data. It does not have direct knowledge of the underlying data source, thus achieving the desired separation of concerns. Dependency injection. To decouple the application's components, the repository can be injected into the business logic layer using a technique like dependency injection. This allows for easier testing and the ability to swap different implementations of the repository without modifying the dependent code. Example usage of the repository pattern. Consider a web application that manages user accounts. The repository pattern can be applied by creating a user repository interface defining operations such as create user, get user by ID, update user, and delete user. A user repository implementation could use an ORM, object relational mapping, tool like Entity Framework or Hibernate to interact with a database, handling all the necessary CRUD operations. The business logic layer would then depend on the user repository interface to perform user-related operations without being concerned with the underlying data access implementation. Let us consider this with simple code for example. Repository layer. The repository layer acts as an intermediary between the data source, example a database, web service, or file system, and the rest of the application. Its primary responsibility is to encapsulate the data access logic and provide a consistent interface for data retrieval and manipulation. Within the repository layer, each entity in the domain model typically has a corresponding repository class responsible for handling data operations related to that entity. These repository classes abstract away the underlying data storage implementation details, allowing the rest of the application to work with entities without being aware of the specific data source. Service layer. The service layer sits between the repository layer and the controller layer. It acts as a bridge, orchestrating the business logic and utilizing the repository classes to perform data operations. The service layer provides an abstraction of the business logic and exposes methods that the controller layer can consume. It is responsible for validating data, applying business rules, and coordinating multiple repository operations, if needed. Controller layer. The controller layer is responsible for handling incoming requests, processing input, and producing responses. It acts as the interface between the users or external systems and the application's core functionality. Controllers utilize the service layer to perform the necessary operations based on the incoming requests. They receive data from the client, validate it, invoke the corresponding service methods, and return the appropriate response. Additionally, we can consider following points also. Caching. The repository pattern can be extended to incorporate caching mechanisms, improving performance by reducing round trips to the data source. Unit of work. In complex applications, the repository pattern can be combined with the unit of work pattern to manage multiple repositories within a single transaction, ensuring consistency across operations. In the end, we can say that the repository pattern offers an elegant solution for managing data access and promoting separation of concerns in software applications. By encapsulating data access logic, it enhances code maintainability, testability, and reusability. By adopting the repository pattern, developers can achieve flexibility, scalability, and modularity in their applications, allowing for easier adaptation to changing requirements and future enhancements. With its clear separation of data access and business logic, the repository pattern has become a widely adopted practice in the software development community. Thank you all for watching. If you found this video helpful, please like and subscribe to our channel for more exciting content. And don't forget to leave any questions or suggestions in the comments section below. Until next time, happy coding!